And what you're joining us for here is our Teaching with Tinkercad webinar. Specifically, this is webinar 4 of this school year, and it's called Teach Physics with SimLab. And my name is Jason Erdreich. I'm a STEM and design educator working with the Autodesk and Tinkercad team to provide resources like this webinar to all of our Tinkercad teachers. And I'm joined by my co-host, Randy.
Hi, I'm Randy. I am part of the Tinkercad and Instructables team here at Autodesk, and I help out with the community, and I'm really happy to be here helping on the chat and helping facilitate this webinar.
Yeah, thanks, Randy. And I also want to give everyone a huge shout out behind the scenes. So I'm joined by a wide range of Tinkercad members and team members here with me, like I am every webinar, that's helping not only put this thing together, but they're going to be working throughout the night in the chat, dropping resources, dropping links, and you're going to get a chance to see them face to face and chat with them directly during our Q&A later in the webinar. So Teaching with Tinkercad, as I mentioned, it's a series for the school year that we started 4 webinars ago, and it's to be held virtually every other Thursday at this time, which is 7 p.m. EDT or 4 p.m. PDT. But we are also tweaking our schedule a little bit. So we've gotten some feedback from our attendees, which is awesome. So looking for the remainder of the year, we are looking to potentially move things around. So make sure that you keep up to date with the Tinkercad blog and the webinars page, because we're going to be posting potentially a couple different events and different things that you can check out in the coming weeks. As I mentioned, today's webinar is Teach Physics with SimLab, and our next webinar, which is going to be on November 16th, is going to be Get Started with Code Blocks. And I'm excited I'll have a new co-host for that one that's an expert at that they'll be able to talk about and run through. So that's one to definitely stay tuned for in the next 2 weeks. So we're going to drop a poll. We'd love to know what you teach with Tinkercad, specifically with your students here as we bring up a poll. So hopefully that comes on your screen in just a moment. If you could fill that out, again, that's going to give us some good insight into who we have here, as well as kind of just gauge what subjects you are coming from. So I'm seeing a lot of variety here in the poll. We'll give everyone a minute or two to answer that, which is awesome. Lots of technology teachers, which is such a broad term. Of course, some engineering folks and art and math and science, and also some other. If you're saying other, we'd love to know what the other is. So drop that in the chat if you haven't already. So that's cool. I'm seeing some music teachers, which is super fun. That's awesome. Also lots of hellos. And again, thank you for saying hi in the chat. So that's really cool. So that's great. So I'm seeing a lot from the technology and engineering fields, which is where I personally came from as a teacher, but also a bit of the diverse subject areas, art, math, science, and a lot of others, some industrial design. That's very cool. So that's awesome. So thanks for that. I'm going to try to kind of cater the SimLab conversations to these different subjects as we chat tonight. Now, let's talk about how to participate. This is going to go kind of quick. I'm going to cover a lot of content. These slides are going to be shared with you as well as this webinar is being recorded. So in the next day or so, we're going to follow up to all of our attendees, share the slideshow, as well as share the recording so you can always go back and review all the things that we chat about. You can also ask questions. We recommend that you use the Q&A feature. So the Q&A feature in Zoom will allow us to see your questions. It won't just disappear in the chat. And as I mentioned, I have a whole team of Tinkercad members from the Tinkercad team with me that's going to be working to answer the Q&A, and everyone's going to be able to go back and see those questions while we answer them. So that's going to be the best way to really participate as we're kind of running through this. And also, as I mentioned, there will be a dedicated Q&A section at the end of the webinar where I'm going to bring all my team members on the screen here so we can really kind of dive into your questions that you still have at the end of the night. So what is Tinkercad? I saw that potentially for some of you, this is your first one joining us. So I'm going to briefly overview what the Tinkercad application is before we dive in. There's essentially 3 different opportunities for you to design different things in Tinkercad. We have our 3D design, which is where we're going to spend most of our time tonight. We have circuits, and we have code blocks. Now, the 3D design, as I mentioned, where we're going to be tonight, is really allowing you to manipulate and combine shapes to make just about anything. So we can group shapes, we can combine them, we can cut them, we can create pretty much any type of invention in a 3D world, including adding physics when we incorporate SimLab, which of course is our goal and theme for tonight's webinar. Circuits allows you to actually interact with electronic components, just like they were on the workbench or on your table in front of you. So you can actually wire buttons and LEDs and batteries and potentiometers and a bunch of other electronic components, including microcontrollers like an Arduino or a microbit, to actually program and wire analog and digital electronics in a simulated space. And code blocks is a familiar sight, perhaps, if you've done a block-based coding language before. So it might be familiar to your students, depending on what you're teaching. But it allows us to apply block-based coding and computer science principles in a unique way by making 3D geometrical shapes using our code. And as I mentioned, that is the theme of the next webinar we have in 2 weeks. So if you're interested about learning that one or more about that, we definitely hope that you drop by and check that one out. I'm pretty excited for that one too. So Teach Physics with SimLab, our webinar number 4. SimLab is a feature that was added to Tinkercad sometime last year, so it's a relatively new feature, and it allows us to add physics and motion to our 3D designs. So we can see how they might interact if they were real materials and objects sitting in front of us in our real world with gravity and all the other things that we have to deal with here on planet Earth. And a question I'm often asked is, why SimLab? I think it's kind of obvious that it's fun to maybe throw some objects around or drop objects, but why is this important, or why should we be integrating this into our class? If you attended the webinar about 2 webinars ago, when we talked about leveling up with Fusion 360, we talked about how professional CAD designers or engineers use CAD software like Fusion 360 to create and simulate their products before they actually manufacture them. And this is incredibly important. Let's say that we're designing a product that has to withstand a certain amount of force, like a helmet for a bicycle. I need to know that it's going to be able to withstand those forces. And while I could maybe manufacture it and then test it and do a crash test and then do another one and another one, being able to simulate these things in CAD software allows us to do that at a much faster and much more efficient rate. So it allows designers to prototype and make multiple iterations of their designs super quick. Because SimLab has been added to Tinkercad, younger students and our youngest creators that are in Tinkercad now have the ability to kind of sort of do the same thing. So they can actually design their models and see what it's like if we drop them. They can allow objects to collide and see what happens when 2 objects of different materials interact with one another. So if they're prototyping something like, let's say, an egg drop prototype, which is what the image on the top right is, and this is one of my favorite projects from my classroom, they could kind of see, will this land and not fall over? Will my egg stay in there? And that allows them to prototype before they actually build, which is, of course, a real-world skill, and allows students to kind of go through their designs and refine them in a more supportive and effective way. Or we could challenge our students to actually imagine and hypothesize how things might work together, like making a Rube Goldberg machine. And this example was made by a Tinkercad user, CMF Design, and it's a really cool way for students to actually be challenged to make things interact and collide just like they were right in front of us. So there's a lot of great career connections and real-world examples about why SimLabs might be beneficial. And again, as you'll see tonight, it's really easy for students to get started with. So we're going to run through with how to actually get started with designing in Tinkercad before we show how to implement motion and physics and things with SimLab. We're also going to talk about some featured projects. So I'm going to share some really cool SimLab projects that I pulled from other Tinkercad users to start to inspire you and give you some ideas. And we're going to learn how to incorporate SimLab into your classroom, where we're going to kind of go back and talk about classes and activities and potential projects that you can start to implement right away. And of course, we'll end with the usual tons of resources and fun, exciting events happening in the Autodesk community before we dive into our Q&A. So getting started. First thing you have to do is log into Tinkercad, right? Which you can, of course, do using a free Autodesk account, or by signing in with a supported social account, or by even creating a seat. So if you're a teacher, you can actually make a seat, which would let your students log in without any account. So there's lots of great ways that both students and educators can log into Tinkercad. And of course, it's always free and works on pretty much any device you might have in your classroom. We then want to create a new 3D design. So as I mentioned, we can do 3D designs, circuits, or code blocks. SimLab doesn't have its own design button per se. It's built into the 3D design editor. And then from there, we can pretty much make any of our 3D shapes work with SimLab. So I'm going to just very quickly switch my screen here. Okay, so I'm in a new and blank 3D design that I've created. So as I mentioned, in the 3D design window, you can pretty much drag these basic shapes and really make just about anything, right? So if I wanted to make, let's say, a ramp, like so, I can just manipulate this basic wedge shape to make that ramp. And now, just like with any of our 3D designs, I might want to edit my work plane. So for example, I can make my work plane a little bit bigger in my work plane settings. And if I wanted to, I could change my unit, though that's less important for our simulations. It's more of the space and the shapes that we're dropping in. So I can give myself some more space to work with. And I could combine my shapes. So I can put in any measurements if I want, and I can actually combine some shapes together. So I'm going to give my ramp a little bit of a landing here. So that way it's just not a total downhill decline. I'm going to give myself a nice little platform at the back of my ramp. I'll let you guess to see if you can think what I might be building here. It's not the most creative design just yet. We'll get to that. So I'm going to combine my box shape with my ramp shape, maybe a little bit more smoothly if I can. Doing Tinkercad modeling live is always a fun thing to do. Really test your skills. Here we go. Something like that. Nope, not quite. Here we go. Even better. Okay, close enough. And I have my ramp. And then maybe I'm going to put some objects in front of my ramp. Like so. Okay. And then something to knock these objects over, like a sphere, which I'm going to lift and put over my ramp. And I apologize for the not super aligned ramp, but we're going to leave it. Here we go. Something like that, right? Now, if this was something in the real world, I would think that if I dropped the ball, it would roll down the ramp and hit the boxes. And this is fun, right? So you can challenge your students to hypothesize what might happen. And SimLabs allows us to bring that to life. I can hit this little falling apple symbol in the top right corner, which brings us into our SimLab editor. And in SimLab, we can set our objects to be two different types of objects. We can set things to be static, which means they don't move, or we can set them to be dynamic to move. So if I click on my ramp, this ramp isn't supposed to move. So when I select my shape, I can toggle it to be static, which is right here by saying make static, or I can hit Control M. By default, these shapes, when they come in, are our dynamic shapes. So all of these shapes are designed to move. The other thing we can do is we can change our material properties. So for example, I might click on this ramp and say that this ramp is made from concrete. And you'll notice that we actually get these material properties. We'll get its density, its friction rating, so we can actually see different properties as well as set these things in SimLab. So I might make these little brick thingies. I'm going to make these polystyrene or styrofoam. And I'm going to make this ball rubber, like so. Then all we have to do is push this play button down here, and gravity's applied. And we'll see exactly what happens. And like I predicted, the ball fell and knocked over those bricks, which is kind of cool. Something that's really cool is now we have this timeline, and I can back this up and rewind and play this frame by frame and really inspect my design, which is awesome. And the cool thing is, as we manipulate our materials, right? So if I change these to not be polystyrene, let me make these also something really heavy, like steel, okay? When I drop it, it's going to have a completely different interaction, right? Bouncy rubber can't knock over steel. So that allows students to really, again, interact with these materials in this simulated environment and see how things go. And something that's really cool is you don't have to design your models to drop like this, right? So I have the ball fall because I have it lifted above my ramp. I'm going to go back to my design, and you can just fluid go back and forth, which is super cool. So I can just go back and forth, modify my design, prototype, and then bring it in. I'm going to actually lower the ball so it's sitting on my little ramp shelf thing, and I'm going to go back into SimLab. Now, when I press play, the ball doesn't roll. And actually, I'm just going to set these back to be something really light, because let's throw some objects, because why not? So let's make these ice, and I'm going to make the ball steel. Let's play with this. When I press play, the ball doesn't move, right? Because it's not falling or rolling necessarily. But whenever I click in SimLabs, I can throw something. And they're these fun random objects. And I have this lip, unfortunately, that stopped my ball from rolling. But that's the good prototyping and thing where we can see, as we modify our designs, potential flaws in our design, that the ball wouldn't be able to roll over this imperfection in my design. Fortunately, I can just come on over here and throw something manually at my bricks if I want to knock them over. And one of the new simlab features is actually the fact that you can look at the different throwables and you can select different ones or let it be random if you don't click on one, or you can select a range of throwables. So that's a fun new feature. I love the recent jack-o'-lantern for Halloween. So shout out to Tinkercad team. And I also know that there's even more simlab features on the way, which maybe we can talk about a bit more in our Q&A. So again, this allows me to kind of experiment and see what would happen with my 3D designs. And to show you what I'm talking about, let's make a new one where I want you to kind of predict what would happen, because I'm sure you've experienced something like this in the real world. But what we're about to do is we're going to bring that into our digital world. I've just grabbed a popsicle stick, okay, or a tongue depressor, depending on from where you are in the world. And I'm just going to tilt it up at an angle like this. And I'm going to bring in a little pyramid shape like this and put it under. And maybe a slightly less angle. Let's see. You guys see where I'm going with this? And I'm going to put a box right here. And we're going to grab another sphere. We'll make it really big just in case we accidentally miss, and put that right here. Now, I want you to predict what you think is going to happen. I'll give you a second to think about it. Okay. I think the red box is going to go flying in this direction. That's what I think is going to happen, because I built something like this in class before. That's what I think is going to happen. Let's find out, though. Let's test our prediction. I'm going to set the ramp piece to be static. I'm going to set my popsicle stick to be soft wood, because that's what it would be. I'll set this ball to be something heavy like steel, and we'll make this maybe bouncy rubber. It's a fun thing. You can also tweak your colors and stuff. simlab's great. So I think the box is going to go flying. Let's find out. Well, it went flying, but I don't think it went flying in the direction I thought it would. So let's back this up here a little bit. Let's rewind. Yeah, it looks like it went the other way. It looks like it started to slide off my popsicle stick right there. If I zoom in, if I go through my rewind, we can see that my prediction was wrong, right? Now, the cool thing is, as I mentioned, I can just go back to my design, tweak my prototype here a little bit. Let's add a little shelf piece that I'm going to group with my popsicle stick, like so. And let's retest. So now I have this little shelf piece. I want it to go flying in this direction, and it does. That's perfect, right? So simlab is a great way for your students to do exactly this. They can experiment, they can see how materials would act, they can test their designs, they can improve their designs. There's so much to it that we can really start to incorporate in not just the typical design and technology class, but your science class all over. And then the really cool thing is, not only can you do this live on your screen, we can hit the share button, and this allows students to download this simulation, right? They can create a video from this. They can save a screenshot. They can crop it. They can share it. So as they're doing this hypotheses, they're experimenting, perhaps you have them putting this together in some type of slideshow or presentation, they can actually create a video and share their simulations frame by frame, or grab an image and even crop it and do whatever they need to do to make sure that it's in the right format to share with their medium and their classes. So lots of really, really awesome simlab features. And if they've already experimented with 3D design, really it's going to feel super intuitive, because it's, again, based on that 3D design editor. So something that your students potentially have been working with for quite some time, which is super exciting. Now, the next thing I want to do is I want to show you some featured ideas, featured projects in simlab, just to give you some inspiration. I'm going to give a shout out to everyone that created these. These are not my creations personally. So this is called a simple scale, which is from the Tinkercad learning page within the blog. And everything I'm sharing right now is going to be linked in the slideshow. So if you want to grab these designs later, you'll be able to do that. They're all linked in the slideshow that's going to be sent out to you. So the cool thing about the scale is that each of these cubes is set to be a different material, right? So I can see that this one's set to be steel, this one is ice, this one is hardwood, and this one is plastic. So this allows your students to make hypotheses and predictions while also interacting with both SimLab and the 3D design editor. So I can actually grab, let's say, one of these cubes. This is the steel cube, and put it in my cup. And then I'm going to grab my plastic cube and put that in the cup as well. And I would predict that the scale would lean towards steel, but you never know. Let's find out. Go to SimLab. We can see we have our models in there. Push play. And yeah, we were correct. Prediction was absolutely correct. I was right this time. I was wrong earlier. Totally right this time that the steel is more, has greater mass than our plastic. So the scale tips. So really fun science lesson there. Another cool SimLab example from the Tinkercad learning account is this really nice basic cars, right? So these are simple cars that are set up to slide down a pretty simple ramp, okay? Everything's preset in this design. So if I press play, we can see that our cars are kind of sort of rolling down. And I know that there's some new features coming out that allows you to create different types of axles and things like that on the radar. So stay tuned for even more ways to enhance this coming out soon. And actually, I got to give a shout out to another Tinkercad user. Tinkercad user account Speedy071 kind of took this, leveled this up, and created this Pinewood Derby simulator. So this design's super cool. And I like that when you apply the materials in SimLab like this, you kind of get the texture, right? So we can see some different wood texture on this wood ramp, as well as the different cars and things. So let's see what happens with this. Pretty awesome. I like that, right? So the different car design. So a really cool simulation feature there. I also like that there's like this little stop strip in the design. So again, this is super cool, really well made, and this is linked in the slideshow. And something that's fun with this, right? Let's say that you provide a template like this to your students. Perhaps we can then actually go in and experiment with, again, masses, right? So even in this Pinewood Derby, can I click on this car and change this material? So what if I make this one concrete? And what if I make this one rubber? And I'm just going to make each one of these a different material here. And we can then, again, experiment with how these materials might interact with one another in this fun kind of simulated way. And while this is a virtual prototype, perhaps the next step, depending on what your class would be, is students can actually then maybe prototype this in the real world, right? This could be the first iteration of a project, of a design. And then students might go ahead and actually try to create something like this and replicate something like this in the physical world in the classroom. So again, super awesome design from the Tinkercad community. I have another one that's really cool. We've kind of talked about cars and scales and mass. This is a domino project. And many, many months ago when SimLab first came out, I made a cool domino project on my YouTube channel that I got to be honest, is completely put to shame by this one. So this is the Great Pyramids of Dominoes by the Count Henry Kai. And again, it's linked in our slideshow here if you want to see this and see the official page. And we can see that really a lot of time was put into making these dominoes. In the last Tinkercad webinar, Tinkercad Tips and Tricks, we talked about the duplicate tool to make patterns. I could suspect that that tool was used to make something this meticulous. So if you haven't seen the webinars, I know somebody dropped in the chat earlier that you can go back and can watch them. So you can definitely check out how to use the duplicate tool to make something like this. But let's push play. That's super satisfying, right? Awesome. I love the extra towers, really cool design. And again, because we can do our frame by frame, we can change our angles and really check this out. So super satisfying. Unlike the real world, when you're doing this on your kitchen floor and you accidentally knock one over and have to start over, SimLab just let me back up and rewind. So really, really awesome. Awesome strategy and a really cool project to challenge your students to make something like this. Definitely incorporating the art as well as technology and design into this. So really, really cool. Somebody, again, another project from the Tinkercad Learning is actually a marble maze. And this is one of my favorite STEM projects. I love doing paper engineering challenges. So making a marble roller coaster is one of my favorite things from my makerspace when I was teaching at the middle school. And I love that this is just a really cool design with a series of marbles and funnels. And let's let this one play out. Orbit around while it's running and look at it from all different views. So such a cool project. Lots of meticulous and design gone into actually creating this thing. Really, really cool. And again, perhaps this is, if this was a design challenge, students could prototype what their paper circuit might, or paper paths and paper roller coaster might be using Tinkercad, which could save some time. I know that we've tried to build some marble roller coasters in my classroom way before this was added, and lots of trial and error, which of course is a great design process and a good way to learn, but allowing us to simulate and kind of reiterate and redefine our designs a little bit ahead of time definitely might make not only more real-world connections come into the classroom, but give students some really, really awesome learning experiences as well. So super cool. Love this project. And we can, again, wind back and check that one out. So that one's on the Tinkercad learning account, and again, linked in the slideshow if you want to check this one out. I love the marble drop. Very cool. And my last featured one from the Tinkercad community is one called a Galton board. So it's kind of like, we used to call these Plinko boards where I'm from. So kind of like a classic math arcade game. And my school, we used to do a probability carnival where students had to calculate the probability of a carnival game. And then we got to build those. And it was sort of an interdisciplinary project. So this one has a lot of marbles. So they kind of took the last one and really stepped it up here, as well as our Plinko assembly. And I'm sure if I was a math teacher, I'd be able to tell you the probability of which slots, but I'm not going to pretend like that's my area of expertise. I'm just going to push play and we'll see the marbles fall. Really mesmerizing design. This one was created by account ZDP189. And again, it's linked in our slideshow. So another featured user project on our Tinkercad blog, which will be linked. So you can check this one out. You can make a copy of it, which is what I did to be able to go in and manipulate all these. So anything that's listed as public, you can share and collaborate and make a copy of, and super, super cool. We also talked in the last webinar, Tinkercad tips and tricks, about how to make your materials transparent. So this board is actually a transparent shape. It's not like a hole. So it's not a hole shape that we'd use to cut in our 3D designs. They actually set this to be transparent just so you can actually see. So you can see how the marbles are going through. And it's interesting, again, if I was a math teacher, I'd be able to talk really, really well about the different probability and why are they all going in here. But I'm not going to pretend like I fully understand that. I can make 3D models all day, and I'll leave the math experts there in the chats to tell me about these probability and the statistics here that's going on. But super cool experiment that we can simulate and integrate into an interdisciplinary learning class. So I love this one, and a great combination of the shapes and things as well. So super awesome. Now, let me go back to my slideshow here to start talking about actually bringing these things into the classroom, right? So I've just hopefully provided some inspiration, different things you can do in simlabs, different types of activities, different types of hypotheses that your students can start to do, right? But what is the best approach? Well, first off, as I mentioned, any 3D design can be turned into a simlab simulation, right? We can push that button, we can see how physics could be applied, how the materials might interact, and how the shapes could collide and things like that. So that's super cool. But what about actually, supporting students as they create? And in the very first webinar, we talked about creating classes and activities, and I think that's a great resource for implementing SimLab into your classroom. So first, start by considering potentially a design challenge. One that if you are like a STEM teacher where your students are doing a lot of problem-based learning, if they're building and things like that, what is a design challenge that they might actually build? What is something that we could potentially try to recreate? So one of my favorite ones is the Rube Goldberg challenge, which actually there's a really great official Rube Goldberg contest if you've ever seen that. But essentially challenging my students to start from point A and do a very, very simple task in the most complicated way possible. So this is a model that I've created that I'll pull up in just a sec, where students have to start in one corner and make a model to feed my fish. So they have to knock over the fish food, and this is my challenge. But as I mentioned, perhaps it's a roller coaster challenge or a catapult challenge or any of the other cool things that we talked about, even an egg drop challenge that is eventually going to be in the physical world. We can start it here as an activity in Tinkercad to begin to prototype. And you can create an activity on any one of your classes. So if you haven't done this before, you can create a class in Tinkercad. And we talked about this in webinar 1, which you can review, where you can invite your students, and that allows you to manage student accounts. That allows you to manage your students' designs. That also allows you to easily add feedback. I saw somewhere earlier, somebody was asking about putting notes or feedback. You can leave notes in 3D design. So you as the teacher could go through your class, look at your student designs, leave feedback for them, which is great. So I might make an activity called Rube Goldberg Machine Challenge or something like that. And then I can actually add a design, a starting template for my students to work with, where I could create this and I could attach this to any activity. I can also attach it to multiple activities. So let's say, for example, I have multiple classes. I can use the same design in all of them if I wanted to. And then students can actually copy that, duplicate it, and manipulate it to actually create their designs. So let me go back to Tinkercad here. Bear with me for a second as I switch my screens. And I'll show you exactly what I'm talking about. So in my Tinkercad account, I have a class called Demo Classroom. So these are just student demo accounts that I've created for webinars and things like these. And I can make an activity. So we have a bunch of activities here, right? But it's super easy just for me to click New Activity, name it something like Webinar 4, and list that it's an example activity, or potentially put different constraints and things like that. I can give these descriptions or instructions to students. I could put a link here to something if I needed to, and students can actually see all of the resources I provide. If I'd like, I could actually hit this Create New Design button, and I can make a new design right here in the activity, which again will be shared with students that they can start from. But I've already created this Rube Goldberg design. So if I head down to my projects, and there are many, I've already created this Rube Goldberg challenge template, and I'll show you what it looks like. Essentially, I've set the work plane to be what I want it to be. So I've gone in here and I've made the work plane much larger. And I've also put a little starting position, as you can see, and I've created my fish tank and my fish food. Now, something cool is all the settings transfer. So the fact that I adjusted this work plane size, if a student copies this document, that transfers. So they will get those settings. Same thing if I change the unit from, say, inches to millimeters or whatever it is, those settings will transfer as a student copies the design. The other thing that I've done is I've locked some of these shapes, right? So I don't want the students to manipulate or change the size of my shark tank. So I've actually locked this shape. I've also locked this table. So the only thing that can be edited is by adding shapes to this work plane, and of course, eventually knocking over the shark food. And because we can throw things, even though I don't have a really cool, really fancy Rube Goldberg here, I can actually go into my simulation like this. And if I click enough with a throwable, let's see, can we feed the sharks the lazy way? Yes, we can, right? So I can knock that over. But of course, that's kind of lame. I want my students to design something to do that in as many steps as possible. And something that's really cool about this also is that the materials I set also transferred, right? So when I made this, I set this cup to be a certain material, and I set the food to be a certain material, and I set things to be either static or dynamic, and that all transfers, which is really awesome because I've already created this design. I've made this as a template. And if a student copies and tinkers this from my activity, they'll copy and tinker it how I create it, which is super awesome. So that's really fun. So if I go back to my documents here, I mentioned that you don't need to make a new design to attach it to an activity. I can find my Rube Goldberg challenge, which is right here. I can click on the properties, and I can just add to a class activity. So I can click Add Class Activity. I only have one class in this teacher account, so I only see demo class. But let's say I had a class for every subject I taught or whatever it might be. I could actually select any one of my classes, and I can also see all of my challenges. So the webinar 4 was the one that I made here with you, but I can add that to my design. And if we head back to class, and if we go back to my activity, we can see that the design is now here. And that's a really handy tool if you especially have multiple classes, because then of course you can make a single design, attach it across all your classes, all your activities. And that's a really powerful tool as a teacher to be able to post these things and share. I also see somebody asked, can you unlock things, or can students unlock things? The answer is yes, and I see that Nicole also answered that. But just to clarify, I set shapes to be locked because I didn't want them to accidentally click or drag. But when they make a copy of this, they have full ownership. So if they wanted to change something, like if they wanted to change the shark tank, in theory they could. But for me as a teacher, that would be one of my constraints in the challenges, where I would say, remember, the tank and the table and all the locked shapes should remain. And the only thing that my students should be manipulating is where they're starting from, and then of course completing the challenge. Just like if I was going to build something like this, I would set those different constraints to aid my students as they engage in this design challenge. So SimLab, awesome tool, built right into the 3D design editor, where you can create really just about anything, as you already could, but also apply your real world physics, where your students can be making predictions, manipulating shapes, changing things. Even, I'm going to go back to this one because I love this one, raising this up and seeing if something like that were to change. It just brings in both the scientific method and the engineering design process as students are kind of manipulating and predicting their shapes. That went really far. That was exciting. I've done this 1,000 times and I still get excited about it. I'm sorry. I just get super, look at that. I love how it goes off the distance. Again, shout out to those Tinkercad engineers for making such an awesome resource. So let me pull it back to my slideshow because we have a couple more things to talk about before we dive into our Q&A. Let me just switch my screens here. So quick recap. SimLab is built into 3D designs, as I said, and students can be applying their real world physics. And as I mentioned, these slides are going to be shared. So if you want to run back, all the different things I mentioned like this, everything has a screenshot. Every account or every project I shared has a link. So that way you'll be able to see all these different designs once we share this slideshow. So really cool resource coming out to all of you. So thanks again for being here. When students are applying their properties, they can of course manipulate them and see how they may interact. And again, this allows students to bring physics and all these other really exciting things from the real world right into their 3D designs, which is super awesome. Now, I want to give you all a huge shout out. Thank you for being here live. We, in addition to sending this slideshow to you and the recording of this webinar, we're also going to be sending you a professional development certificate for attending tonight's professional development. So again, thank you for being here live. We really appreciate it. And before we dive into our Q&A and answer some more questions, which I see lots of great questions, which is awesome, I want to bring Randy to the microphone here because he's going to talk about some exciting resources and events happening in the Autodesk community.
All right. So first of all, Instructables, another Autodesk website where we have a lot of tutorials for teachers. We have a whole teachers page where you can go sort by subject and grade and kind of learn things related to Tinkercad or hands-on learning that you could apply directly in the classroom. And then a lot of those projects are also mirrored over onto Tinkercad projects. So if you don't want to go over to Instructables, just click projects at the top of Tinkercad and you can see some really great hands-on Tinkercad projects. And Instructables also has a number of contests currently running. One is the first time author contest. So if your students or you have never posted an Instructable before and you want to create an account and participate, that's a good one to do it. And we have special judges prizes for best use of Tinkercad or Fusion 360 if you are working with more advanced students.
I got excited about that one because it closes in just a week. So let's make sure that, we got to get on this one because that one's coming up quick.
Right. You have limited time to be a first-time author, but we'll run more of those in the future. So if you miss this one, maybe don't wait for the next first-time author contest, but you can. We have the jewelry contest, which is a fun one. And there's a special Tinkercad Judges Prize for budding jewelry designers and people who are really into fashion. It's a fun one. There's always a lot of great designs in there. We have the Make Some Noise contest, another perennial fun contest where anything that makes noise, whether it's an instrument or synthesizer or it doesn't even have to be a musical instrument. It could just be anything that makes a racket. It's actually a really fun contest.
I feel like SimLab could be integrated into that one too. You can have things like, I feel like while we couldn't hear what my shark food sounded like, I feel like that made a great noise if that was in the real world. Probably integrate that a little bit there too.
Great. And then robotics contest, this is a really good one for all of you STEM teachers. So if you're doing anything related to robotics, if you're building a robotic component or a robot, or you have students who want to kind of work independently, this is a great contest for that. And then the project-based learning contest is a project for educators to share their project-based learning curriculum that they use in the classroom. And there's $40,000 in prizes, and there's a whole lot of prizes and a whole lot of categories, and I highly recommend to check it out. You have still have a month and a half to submit to that contest.
Awesome. Thank you, Randy.
And I will say, in terms of challenges on Tinkercad, we run them on the blog, and stay tuned next week for some exciting new challenges. So keep your eyes peeled there. There's going to be some simlab challenges coming up, and you should definitely stay tuned for that.
Awesome. Thank you, Randy. So before we dive into the Q&A, as a reminder, our next webinar is going to be on the 16th, and it's all about Get Started with Code Blocks, and I have a guest speaker coming in who is a Code Blocks master. So super excited about that one. So definitely stay tuned. Really unique feature in Tinkercad that we haven't talked about much in the webinars thus far. So totally worth coming by in 2 weeks. And I want to open up to our Q&A. Before we do, I'm going to stop sharing my screen just so you can see the Tinkercad team that's been with me this whole time, right? So again, huge shout out to all of these folks. They're the reason that we've already answered 28 questions in the Q&A. So a big thanks to all of them for working really hard to drop links and things into the chat as we've been going. And if you are going to sign off before we open up this Q&A, that's totally fine. We understand. And as I mentioned, we're going to be sharing these slides, a recording, a PD certificate, and everything with you in the next day or so. But if you'd like to stick around, we're going to open up our Q&A again. But again, I just want to thank you, everybody, for joining us live this evening or afternoon or whatever time it is, wherever you are. And of course, thank you again to my Tinkercad team here for helping me coordinate and run this webinar. So